Hello, my dear students. Our lesson today is the set of integers. We studied before the set of counting numbers. The set of counting numbers 1, 2, 3, 4, and so on. And also we studied the set of number, the set of natural numbers, which is 0, 1, 2, 3, and so on. We can represent the set of natural number in the number line, as we studied before. Here we have 0, 1, 2, 3, 4, 5, and so on. If we want to represent 5 minus 3 in the number line, we have here 5 moving from 0 to 5. Minus 3 means back 3 steps. 1, 2, 3 will be here. 2. Moving from 0 to 5. Minus 3, back 3 steps. 1, 2, 3. The result will be 2. If I have another example, 2 minus 5. Use the number line to represent this example in the number line. The number line 0, 1, 2, 3, 4, 5. 2 minus 5. Moving from 0 till 2. This is the first step. And now, minus 5. Minus 5, move to the back 5 steps. 1, 2, where is the third step? Then we need here to put here another number, represent the opposite side. Will be negative 1. Here we have 1, and here negative 1, negative 2, negative 3, negative 4, and so on. So now we have negative 5 minus 5, 1, 2, 3, 4, 5. The result will be negative 3. Here we have the opposite direction represented by the negative numbers. Here in the middle we have 0, and here 1, 2, 3 is called the positive numbers, and here is called the negative numbers. Then the set of integers represented by z equals, in the middle we have here 0, and the set of positive numbers 1, 2, 3, 4, and so on. And here we have the negative numbers negative 1, negative 2, negative 3, negative 4, and so on. And we can represent in the number line. This is the number line, represent the set of integers. Here we have z negative, and from 1 and so on, represented z positive. Here is the negative numbers, and here is the positive numbers, and 0 is between them, not negative and not positive. Then the set of integers z equals z negative union 0 union z positive. Okay, we have another way to represent the set of integers. We know that z negative as it is union. As we know in the number line or in the sets, 0, 1, 2, 3 is called the set of natural number. From 0 till the positive number is called the set of natural number. So we can write it n, natural number. So we have two ways to represent the set of integers. Z negative union 0 union z positive, or z negative union the set of natural numbers. Let's solve these examples using the number line. We have here 0, and z negative consists of the negative numbers, negative 1, negative 2, negative 3, and so on. And the positive numbers, z positive 1, 2, 3, and so on. And if we say 0, 1, 2, 3, and so on, we can represent it using the natural number. Okay? Okay, number 1, Z different, Z negative. Z all the number line, positive and negative and 0. Difference, we can cancel the Z negative like this, cancel the Z negative. Then we have 0, 1, 2, 3 n, which is the set of natural number. 0, 1, 2, 3, and so on is the set of natural number. Number 2, Z different natural number. We cancel here 0, 1, 2, 3, and so on. Then we have the remainder will be Z negative. Okay? Number 3, Z negative intersect Z positive. We know that intersection means the common element, the repeated element between negative and positive. We haven't any common element between them. Here is the negative numbers and here is the positive number. Then the intersection will be foil. Number 4, Z intersect 0. We know that the intersection is, as I said before, the common element. We know that 0 belong to Z, all of the number line. We have here 0 belong to this set. Then the result will be also 0 because the set of 0 subset from Z. Number 5, the set of natural number different Z positive. The natural numbers 0, 1, 2, 3, and so on. If we cancel Z positive, the remainder will be set of 0. Number 6, Z intersect Z positive. We know that here from the number line, Z positive subset from the number line, subset from Z. Then the intersection will be Z positive. And now complete the following example by using belong, doesn't belong, subset, or not subset. We know that belong and doesn't belong, we use it if we have element and set. But subset or not subset, we use it when we're comparing between set and set. For example, in number 1, negative 3 and the set of integers. By using the number line, we have here negative 3 in the number line belong to Z, then the result will be belong. Okay, number 2, negative 1, 3, 5, and the set of natural number. We know that the set of natural number consists of 0 and 1, 2, 3, and so on. The 0 and the positive number. But here we have negative number. Negative 1 doesn't belong to n. Then the result will be not subset. Not subset. Number 3, 0.5. We have the set of positive numbers, Z positive. Just we have 1, 2, 3, and so on. The positive number, we doesn't have a decimal. Then the result will be doesn't belong. Okay? About this example, you can solve this example by yourself. Now, let's start about the absolute value of the numbers. For example, if we have the absolute value of 3, the absolute value of 3 equals what? Let's use a number line. Here, the number line, the absolute value of 3 is the distance from 0 and 3. Let's count the distance between them. 1, 2, 3. Then the absolute value of 3 equals 3 because the distance is 3. What about the absolute value of negative 3? As we said, is the distance between negative 3 and 0. Count with me. 1, 2, 3. The same. The absolute value of negative 3 equals also 3. Then, absolute value of 3 equal the absolute value of negative 3 equal 3. Okay? In general, the absolute value of any number, the absolute value of any number is the distance, its distance from 0 and the number on the number line. For example, if we have absolute value of negative a equal the absolute value of a equals a with the positive sign. Some examples: absolute value of 5, as we said, is the same number but with the positive sign. Absolute value of negative 5 will be 5 with the positive sign. What about if I have negative the absolute value of 3? As I said before, the absolute value of 3 means 3, and put this negative as it is. And if I have absolute value of negative 3, negative as absolute value of negative 3, as we know, this called equals 3, and put the negative as it is. We can add absolute value of 3 plus absolute value of 2. This is equal 3, and this is equal to will be 5. The absolute value of 7 minus absolute value of negative 2. Here is 7, and absolute value of negative 2 equals 2. Then 7 minus 2 equals 5. And if we have the absolute value of 3 equals x, find the value of x. As we said before, here is the absolute value of any number. Give me the same number with the positive sign. Then x will be 3. Okay? But if I have find the value of x when absolute value of x equals 3, find x. Here, as we said, the absolute value of x equals 3. Here maybe the x equals 3, because if we put here 3, absolute value of 3 equals 3, or x may be negative 3, because if we put here the absolute value of negative 3, the result will be also 3. Then absolute value of x equals 3, we have two results, 3 or negative 3. And now we have general exercise in lesson 1. You can solve this exercise by yourself. And I hope you enjoy studying math in Nuzha Language School.